So hi, welcome to lecture series on programming in C and data structures. Today, let us see about. So in the previous session, we have discussed about what data structure is all about and why do we need a data structure. In today's session, let us discuss about the various types of data structure. Generally, data structure falls into two categories. One is primitive data structure and another one is non-primitive data structure. So primitive data structure includes the data types that we have seen like integer, float, pointer, and character, whereas non-primitive data structure consists of arrays, lists, and files. So I hope you are aware of all these things. So we would have used integer, float, pointers, characters. So we would have implemented a array. We would have used list. So and files also you should be aware about. So if you take this list, it is classified into two types. One is linear list and other one is non-linear list. So under linear list, we have two different data structures. One is stack and other one is queue. And under non-linear list, we have graph and trees. So we will discuss about all these types in detail in the forthcoming lecture videos. So here is one assessment for you based on the previous and today's discussion. So which of the following data structure is non-linear type? So there are four options given: strings, list, tag, and none of the above. So do you remember the non-linear data type we have seen in the previous slide? So here string we haven't seen, right? So string is not a non-linear data type. So list is classified into two types. One is non-linear, the other one is linear type. So under linear type we have stack and queue, and under non-linear type we have graph and trees. So none of these two options, graph and trees, are present here. So the answer is none of the above. Next is, what defines a set of primitive elements which do not involve any other element in subpart? So just try finding the answer for this question. So take this as an assessment based on the previous discussion. This slide represents the general operations that we perform on data structure. So whatever the data structure we use, these are the general operations that we perform on the data structure. First one is traversal. So traversal is about processing each element in the list. Visiting all the elements in the list is called as traversal. Next is searching or finding. So this is about finding the element location based on a particular value with a given key. So if you want to locate the element in a list, or if you want to locate the element in the array, if you want to locate the element in the stack, you have to perform search operation. Third one is insertion. So as the name indicate, insertion is about adding a new element to the list, and deletion, again, according to the name, it is about removing or deleting an element from the list. So these four operations we would have used everywhere. So you should be aware of it. So we have one different operation like sorting. Probably you should be aware of this too. So sorting is about arranging the elements in some type of order. So by order we mean either the elements can be arranged in ascending order, or these elements can be arranged in descending order. So last operation on data structure is merging. So merging is combining. As the name indicates, it is combining two lists into a single list. So this is how a data structure is implemented. So whatever the data structure is, whether it is a stack or a queue or tree or a graph, it can be implemented in two ways. One is using array, other one is using linked list. So in linked list, we will have pointers pointing to each nodes. So the values will be stored in the form of nodes in case of linked list. So here, if each of the square blocks represent nodes. So these nodes contain values, whereas in case of array, we represent this as index or fields. So the index of the array starts from 0, and the last index is size of the array minus 1. Similarly, the first node in the linked list is called as the header node, and the last node in the header node linked list is called as the tail node. So this is the difference between the array and the linked list. So array is widely used in case of searching algorithms. If you want to find an element, if you want to search for an element, we prefer using array implementation. On the other hand, if you want to insert an element or delete an element in a more efficient way, If you want to do it efficiently, we will go for linked list. So for the operations such as insertion and deletion, linked list is always efficient. Whereas searching is difficult in case of linked list. On the contrary, searching is easier in case of array, whereas inserting will be difficult. Why so? Consider the array, size of the array is 10. If I want to insert an element in the position 5, I want to shift all the remaining 5 elements once by one position. Only then I can insert. So it will consume more memory. So insertion or deletion. Again, if I want to delete a value in the index, for example, 3, I want to shift all the remaining 7 elements one position before. So insertion and deletion will occupy or will consume more memory in case of array implementation. So array implementation generally is not preferred for insertion or deletion of values. And and it is also this shifting movement is also time consuming. So a sequential traversal from beginning of the list is required to search for an element until it is found or up to the end of the list. So I hope you understand this. So these are the main difference between array and linked list. So here are some benefits of data structures. Uh, Space for each item it stores is more. Time to perform basic operation is less. Programming effort and complexity is reduced. So here are few assessment. So first one, identify the data structure. What does it represents? Yes, it represents pile of plates. So it is arranged one above the other. We can also call it a stacked. So we have stacked the plates one above the other. The second one, it represents from the picture you can see it is Google Map. So maps are implemented using graph data structure. Third is various persons are waiting in a queue to buy something. So this represents queue data structure. And the last one, from the figure itself, we can identify it. Look, this figure is similar to the tree structure and it is a tree data structure. So with this, we end this slide or we end this presentation. So in the previous lecture, we have seen what data structure is about. And now we have discussed the type of data structure with some examples and the way in which it can be implemented. That is array and linked list implementation. We have also seen the difference between the array and linked list. So in the next video, we will discuss about the abstract data type. Hope you understood this lecture. We will meet in another lecture series. Thanks for watching.